Great, thank you, Larry, and good day to everyone. Today we're going to be talking about blockchain as well as other decentralized technologies. So I'm sure everyone's heard about these things. They're gaining popularity by the day. Even Oracle and Google in the past week have talked about having decentralized technology initiatives that they're starting. So especially on the developer end, these things are taking off really quickly. So I kind of wanted to go through an end-to-end high-level thing of what these technologies are and how they can be applicable. So just an overview for the presentation. We're going to start with looking at how things are today. So what it's like to be online today and kind of what are the needs for these technologies. I'll then go into what exactly a blockchain is, some current obstacles to adopting these technologies, a couple of paths forward. So how are we going to potentially overcome these obstacles? I'll talk about when to jump in because a lot of people have heard about this and they don't know if it's good to get in now, to wait for technologies to develop. So I'll talk a little bit about that. And then we'll look at what one of these decentralized futures could potentially look like. So online today, we have people who are interacting and buying and selling services. But one of the biggest issues is that it's really hard to trust someone on the other end of the transaction. If you want to buy music from someone, you can send them money and they could send you the song back if they're honest. Or if you send someone a song and you want to receive money, again, you don't know the person's going to do that. So how we get around this problem is we use trusted third-party intermediaries. So a lot of these names should look familiar. And the idea is that if we trust these third parties and the people we want to work with trust these third parties, we don't have to trust each other. They take that risk out of the equation. But when they do that, there's a lot of things to consider. There's cost associated with this. Either yourself or the other party are going to have some sort of financial cost or perhaps giving up some personal data. There's also this issue of data ownership. We started to get more unified accounts. So in the past, we had a different password for everything, but now most things will go between our Google account or our Facebook account. And this really puts a lot of information in one hands. And we kind of look in, oftentimes people will value convenience and functionality more than their security and privacy. And it's really giving a lot of power to these few intermediaries that are standing between most transactions. There's also this issue that people often sell the data that's given to them. So you might use a service for free and there's no cost associated with it, but they may use your data in a different way to improve their products or even sell off some of that data. And it creates a dependence on these intermediaries. So one of the big things is when you're dealing with a client or dealing with someone else, you really can't do it without these people. In the past month and a half, there's been outages with Apple Maps, Slack, and a lot of the Google services. So we're reliant on these things, and if they don't work, it can really take down what we do. And one of the biggest issues is transparency. So any interaction we have with either the intermediaries or with the person on the other end, it's all tracked on the intermediary servers. So we don't have access to exactly how things are happening. Since they're a trusted third party, we trust that they're doing everything properly, but we really don't know. We can't inspect how they work. And this is one of the things that really gave rise to the idea of a distributed ledger technology. So rather than the intermediary hosting everything on their server, it's distributed to everybody on the network. So in a distributed ledger technology, all the nodes that are on the network are able to see and validate the transactions. People can be anonymous on the network itself, but since the actual ledger of transactions is public, everyone can make sure things are happening the way they're supposed to. And it takes the control out of a single person or individual's hand. And the most common example of this that you've heard of is the blockchain. So what exactly is a blockchain? So this is the same picture we started with. And how things differ on the blockchain is when you want to do a transaction such as buying a piece of music from someone, you take that transaction and you broadcast it out to the network. So everybody on the network is able to get a copy of that transaction, to validate it, and to make sure it's going the way that you said it would. If you were to say, I'm going to lower my bank account by $10 and increase my friend's bank account by $10, that's a valid transaction. If you were to say, I'm going to decrease mine by $10 and increase theirs by $1 million, that's obviously an invalid transaction. So everyone on the network can make sure that what you're doing makes sense according to the network's rules. And the more diverse people that there are on the network, the less likely that these people would be against you. So it creates a distributed trust. There's this idea that unless 51% of the network says what you're doing is wrong, then the transaction is valid. So that allows it to be distributed amongst everyone instead of relying on a single intermediary. So as you use the network and as transactions happen, they naturally build up. And so what happens is these transactions get confirmed by what are called miners. Now, miners are special people on the network that confirm and bundle these transactions into blocks, and they secure them in exchange for getting a financial reward. So a block is this transactions put into a single package, and a label's put on it to make sure that what happens inside is validated. So I like to think of this as a list of contents. What goes inside the block is listed also on the outside, and they do this by creating a hash of the transactions. They make sure that if anything inside the box changes, what's on the label will no longer correspond to it, so you'll know something's fishy. Now, the transactions themselves are actually a hash of the Merkle root of the transactions. So those familiar with Merkle trees, every single transaction will get hashed, and then they'll go up to the Merkle root, and this contains a hash of the Merkle root itself. So over time, we create these blocks, and what we do is we link them together in a chain, hence the term blockchain. So what happens is, if someone was to look at these blocks, and we know that if they change the transactions, the label will no longer represent what's inside, so that block won't be valid. But what if everyone's working on the latest block, and someone wants to go back in time and change an old block? They might think, okay, well, I'll change the content of this, plus I'll change the label, so that the label matches what's inside the block, but it happened in the past. So every block also contains a hash of the previous block's label. So what this does, this allows you to look at any previous block to make sure that it hasn't been changed, the label hasn't been changed, as well as the transaction. So each block verifies its own transactions hasn't been changed, and each subsequent block verifies the label hasn't been adjusted on the previous block. So this creates it that if anyone was to change a block, it would break the chain moving forward. So this is pretty good for transactions, especially simple peer-to-peer transactions, but where blockchain really has gotten exciting is this idea of blockchain 2.0, which has come about largely thanks to the Ethereum network. And what this is rather than doing simple transactions, you can actually put code onto the blockchain. And this allows you to do all sorts of things and completely open up what's possible. So a few technologies that I think are really exciting with this idea of code on the network is an identity wallet. An identity wallet would allow anybody on the network to privately store all the elements of their digital identity and with complete control. So this would allow you to have full control over any information you want online. Rather than uploading things to Facebook, you would have control over that. And this also creates the idea of portability. So let's take the example of Facebook. If you wanted to share a bunch of your stuff with your friends, a bunch of pictures and information, rather than putting it on their server and them sharing it, all that application would need to do is to allow you to share your information with someone else. It doesn't have to be on their servers. You can own the information, you can have it, and it allows you just to share the parts that you want to with the people. And no intermediary needs to have access to those. And it creates portability because if you decide you no longer want to use Facebook and you want to use something new, you could take that information and simply grant access to the new, through the new application, and everybody has that. So there's no worry about downloading your own information or having that in someone else's hands. And there's also this idea of a universal identity. So there are people that are excluded from the digital economy, and this gives them the opportunity to do this. There's also issues with, say, passports. If you're in a war-torn country and you're trying to flee, you get to the border and someone takes your passport, you no longer have an identity. And this isn't something that we think about daily, but it is a real issue. And having something like an identity wallet would allow us to overcome this. There's also this idea of decentralized applications. So rather than using the cloud to host your applications, it's this idea that you can put your application onto the blockchain and it's completely host independent. Anybody or anything can host this. So your application could be running on a server, somebody's cell phone, somebody's blender, anything. You can have anything that's able to host an application could do this in exchange for some small fee or some small reward to host this for you. It also looks at the idea of data ownership and integrity. Kind of as I mentioned with the Facebook example, if you were to say use Twitter and tweet something out, that's your freedom of speech. That's your ability to put what you believe out in the world. But applications like Twitter can actually block profiles and take down people's tweets. If you're using a decentralized application, this would be a way that there'd be no way for them to do that. Only the person that posted would be able to rescind their own comments. And this sometimes gets taken to the natural extreme. These decentralized applications can also turn into decentralized autonomous organizations. So these DAOs, what they are is rather than just your program living on the blockchain, you could have your entire organization on the blockchain. So you could have some developers working on a product and absolutely everything exists on the blockchain, including the payment structure. So you can use what are called smart contracts, which I'll go through in a minute. And this would allow you to actually get paid when certain milestones are hit, for example. So a CEO of a company might have to reach a certain amount of revenue before they get paid or before they receive a bonus. So they could leverage the blockchain, not just for these applications, but for their entire organizational structure. So as I mentioned, what allows this to happen is this idea of a smart contract. And smart contracts are one of the most exciting things on the Ethereum network and the blockchain 2.0, in my opinion. This allows you to exchange any product, service, or asset in a transparent and conflict-free way without any intermediaries. And it can do this because the contract itself is actually code. So when the contract is written, it can define the terms, the rules, the penalties, and the conditions between multiple parties, and it can automatically validate it because it's just code. And it can make sure that the conditions and the penalties are enforced exactly how it was written. This allows nobody to change the terms of the contract. It's not like a contract today that where it could be open for interpretation. It would be available and it would be exactly as it's stated, and the code would execute exactly as it's stated. If you take the example of someone getting paid when a certain target is hit, you can watch that. You can see on the blockchain that that company hasn't hit that amount yet. So if they haven't hit that revenue goal, they wouldn't get paid. Another example would be Kickstarter. For a Kickstarter campaign, you might want to invest in someone's startup, and if they hit their goals, Kickstarter could allow them to have that funding, and if not, it could refund it to you. Well, this would allow it to do the exact same thing without any type of intermediary. The smart contract would serve as that same vessel to make sure all the conditions are met before releasing funds or refunding the amounts. But my favorite example for smart contracts is the idea of purchasing a house. For anyone who's gone through the process before, it's a pretty big ordeal. And once you get to the stage where you're like, hey, I have some money and I want your house, and the seller says, I have a house and I want your money, it's not that simple. You need to go through lawyers, banks, inspections. There's still a lot of intermediaries that get there, even when you both decide you want to go ahead with this. And using the blockchain with smart contracts would allow you to do this much more efficiently. If a person who owns the house had a digitized deed that was available on the blockchain, and you had your currency, which was digitized and verifiable on the blockchain, it would be very simple to create a smart contract that would perhaps say, once an inspection is passed, and I verify that that company who is able to verify the inspection, once that happens, automatically transfer the deed from their wallet to my wallet, and to change the locks from their smartphone to my smartphone at a certain date. This would be able to be done automatically and verifiably without the need for all these intermediaries. So as I mentioned before, there's some current obstacles to adoption. Hopefully by now, the blockchain sounds pretty exciting and you can see some potential in it, but there's some big issues. One of the biggest is the idea of scalability. So scalability in the transaction fees, in the transaction speed rather. Visa, for example, can do 64,000 transactions per second, which is pretty impressive. Blockchain can do 7, and this isn't 7,000. This isn't 7 blocks of transaction. This is actually 7 transactions per second. So obviously it needs to get quicker to be adopted mainstream. And what happens is, as I mentioned, there's these miners who secure these blocks. Well, they only secure the blocks on the Bitcoin network once every 10 minutes. So the miners all compete to get this reward. Every 10 minutes, they run a competition. And whoever wins that competition is able to make the block and get the reward. So if you only require 1 confirmation, that block can be done in 10 minutes. Your transaction may finish in 10 minutes. For larger transactions where they want more confirmations and the average on the blockchain is about 6, it can take up to an hour to process your transaction. So obviously this isn't going to work if you want to buy a cup of coffee and it takes an hour to validate your transaction. There's also this idea of efficiency. When these miners are competing to make these blocks and running this competition, one person's going to win, but everybody else is going to lose. And so what happens is there's a lot of energy and computational waste. So if you look at this energy consumption index, in July 2018, 71.12 terawatt hours per year are being used to mine blockchain, or Bitcoin rather. And this, as a comparison, is the same as the entire country of Chile. So this ability to have these competitions to get the reward isn't actually what's required to make the blockchain work. It's just to verify who's going to have these blocks and do these confirmations. So there's a massive waste. If you're using the entire country of Chile's energy for a technology that's not really mainstream yet, that's obviously a huge problem. There's also this idea of transaction costs. So every transaction you do on the blockchain requires some sort of fee that gets paid to the miners. And when you do this, it's going to cost you a certain amount. So let's say you want to buy a Starbucks for $5. Well, as recently as December 2017, the transaction fees on the Bitcoin network in particular were $34. So if you're trying to buy a $5 cup of coffee and you're paying a $34 transaction fee, that's obviously not going to work too well for you. And you know, 34 was a huge spike, and you can see it's an anomaly here. Typically, every month it bumps up to about $2 and then settles to about 20 cents per transaction. But even at a $2 fee, you wouldn't want to pay a $2 transaction fee for a $5 cup of coffee. There's also this idea of distribution. As I mentioned, the idea of this distributed trust comes because everyone on the network has no reason to work together to collude against you. But what's happened, because these rewards are getting so large, is there's these mining pools that have happened. And these are people that use specialized machines specifically to mine Bitcoin. And when they do this, it gives them a large percentage of the computational power on the network. And their goal might just be to make money. But if they were ever to succeed in getting 51% of the network themselves, or in collusion with a few other large pools, they technically could take over the network. So as I mentioned, there's a lot of paths forward here. So there's some really cool ideas in this path forward. Every one of these ideas I could spend half an hour talking about. So I'm going to be going through them quickly, trying to do a high-level overview. But really, if any of these sound interesting, I just implore you all to research these further because they're very interesting. The first idea to move things forward is to take the blockchain and evolve it. And one of the best ideas is this idea of proof of stake. So rather than running these competitions for who gets to make the blocks, what you do is you have people stake coins or make a security deposit where they put money down and said, I want to work on the network. I want to make these blocks in exchange for the transaction fees. I'm going to put some money up front. And if I do anything that doesn't look right, I'm going to get a penalty and lose some of those coins. So this keeps people honest by making sure that they're actually going to lose versus gain by being a bad actor on the network.
I want to interject there because you're introducing proof of stake, but in Bitcoin they have proof of work, right? And that this is an alternative to proof of work.
That's correct. So yeah, the proof of work, these are called consensus algorithms.
Mm-hmm.
The proof of work is the idea that every 10 minutes you do this cryptographic puzzle to decide who's going to get to secure the block. Where a proof of stake says, rather than having a competition, based on how much you stake in a linear fashion, the more money you stake, the more likely you are going to be to make the next block. So sorry, go ahead.
Oh, I was just going to say, because just like an hour before you came on, I was showing my students how proof of work works in Bitcoin. And you guys remember how the miner had to guess a number that would be added to the hash that would make that hash come up with those leading zeros, and how that gets harder. The difficulty keeps getting harder as they add more zeros. So this is an alternative to that. And it makes instead of harder processing, it's more like you have a vested interest into why you're being honest. Is that about right?
Yeah, that's exactly it. Yeah, it takes me to actually my next point, nice transition. It's much more likely to be distributed because instead of relying on the computational power, it's relying on financial power. So if you wanted to take a 51% stake in the blockchain network, it would cost you $41 billion currently. So not a lot of people have that change to spare to take over 51%. And obviously, the more people that are participating, the better it is. But yeah, it really eliminates the energy efficiencies from the proof of work algorithms, and it puts a better consensus algorithm having it based on less waste and just based on the financial distribution. Another idea.
I'm sorry, Nathan's typing in. He said that Bitcoin uses proof of stake. You have Neo and Ven use proof of work. Excuse me, Bitcoin uses proof of work, and he's got Neo and Ven. What is Ether using?
So Ether right now the Ethereum network is using proof of work, but they're moving to proof of stake.
I see. Okay.
Yeah.
And are you familiar with Neo and Ven?
I'm actually going to touch on not those ones, but actually a few different blockchain technologies in a few minutes here.
Okay, all right. I'm sorry, I didn't mean. It's just he's typing in there. I wouldn't get too caught up. Go ahead.
Yeah, no, definitely, yeah. And that's the thing, is that one of the things to keep in mind is that blockchain has become synonymous with Bitcoin, and so a lot of people think that way. But there's a lot of different types of blockchains out there, and if you look at things and you say like, well, blockchain does a certain thing. Well, not always, right? The block sizes change, the consensus algorithm changes, the network requirements, like how much it takes to control the network. Those things can all change depending on your implementation of the blockchain. And blockchain, one of the great things, it's an open source technology. So you can take the actual code for that and you can actually change that. And you can add to it or make your own blockchain. Kind of the current thing a lot of people are doing is they're building on top of the Ethereum network versus developing their own. But certainly, yeah, different blockchains use different technologies and different consensus algorithms.
And you're probably going to get there, but just to introduce, not all consensus protocols are using blockchain technology as well, right? I mean, Hashgraph is not technically a blockchain. I've heard things in terms of like block matrix versus a blockchain or something like that.
Yeah, precisely. Yeah, I'll touch a bit on Hashgraph in a minute here.
Okay, great.
So I'm glad we're on the same page. Another thing, instead of evolving the blockchain, one thing you could do is you could actually split the blockchain up. And this is this idea of sharding. So you can split the blockchain into different parts. So rather than everyone participating on one large blockchain, they actually work on a couple of smaller blockchains. And what this does is this addresses the speed issue. So if you have people working in different smaller blockchains, they're able to have fewer people on the network, which means fewer transactions, and each one can run a consensus algorithm themselves versus the main one. And this allows things to go much quicker. But the big problem with this is that you could have this, what's called a single shard takeover. So the more you split up the blockchain, the easier it is to control one section. So as mentioned with proof of stake, it costs, for a Bitcoin network, it would cost $41 billion to take it over. But let's say you split it up into 1,000 different parts. well, then it's only $41 million to take it over, which is a lot easier to do. And I know, Larry, you were mentioning with sharding, you had some questions on that?
Yes, actually, we're going to, and it's actually for my students for databases tomorrow. We're going to have to understand the difference between horizontal and vertical partitioning. And I understand sharding is just another term for partitioning. Now, when we do in security, and we're looking at partitioning, we have a choice of saying, if I'm worried about performance and I have, let's say, an employee database, and I say, I'm going to partition horizontally, I'll run records A through M on one system and N through Z on another. And that would be a horizontal partition that increases availability. But if I were worried about a confidentiality issue, I might say, all right, well, I'll run a social security number and any PII on one hard drive, and then all the public information on another database, and that's vertical partition. But sharding seems to be even more granular than that, and I won't pretend to know much about it other than I listened to Good Morning Crypto with Ivan on Tech, and he said that you know, Vitalik is saying that it's coming to Ethereum. It's coming, but it seemed like they got more granular. So yeah, please explain. If I look at these as a database, is the shard going to be, say, take certain attributes out, or is it going to be the certain records would run on a different system? What does each shard represent?
Yeah, so as you mentioned, like horizontal partitioning is typically you would take certain rows from the database and you'd split them up into different, let's say, computational pools. And if someone's saying, I need this particular record, it would route it to the appropriate computational pool. Well, sharding kind of takes that idea to the next level. It actually allows you to have multiple instances of the same schema rather than having it all as one instance. So when you do horizontal partitioning, you only have this one instance of the schema, whereas with shards, you'd actually be living in your own version of the blockchain. So what the programming, the programming has to figure out right now is, like, if you wrote an application and you could, search everyone on the blockchain and you live within a shard, you would think that that's the entire blockchain. Whereas once they make it easy to program between shards, that's going to make this idea take off a lot faster.
Well, certainly they're going to have to reconcile at some point, though, correct?
Well, precisely, yeah. So each of these shards is, each team, as you put it, is a coalition. So they're all working together and they're all verifying their own transactions. And so the main blockchain has all these coalition headers to make sure everything's consistent.
Okay, and we have a question from Nathan. Is sharding equal to forking? No, right? Forking is when, the most famous fork I think of would be Bitcoin to Bitcoin Cash. One of the approaches to making it faster from 7 transactions per second was to make the block bigger, but that changed the entire setup. So it was a different implementation. So a fork go ahead.
Yeah, I was going to say, So a fork is when you actually alter the blockchain. So you can have either a hard fork or you can have a soft fork. So like I said, I mentioned as a hard fork requires all the nodes on the network to upgrade to this new version of the blockchain. So you would actually basically say, okay, like you mentioned, we're going to make a huge change to the blockchain. And this is where something, if you change from like a proof of work to a proof of stake, you may need everyone to upgrade all of their information so that they can all be on the newest version. Whereas a soft fork is more of when there's an inconsistency. So that actually the network can split, saying that they don't believe what's happening on this, and 2 people can decide to go different routes with it.
I'm thinking as my mind goes, I imagine if, for example, Ethereum implements sharding, it will require a fork to make that work, but they're not. They're not just the same thing.
Yeah, exactly. So sharding is splitting up the blockchain into parts, whereas forking is, it is potentially a way, and it's a great question because, like you said, if you go in, when Bitcoin had their big fork, there was people who wanted to stay kind of with the Bitcoin classic, and then you have the people who want to go with the new implementation of Bitcoin. So, and fair enough, it actually does split up the blockchain. So it would be having multiple blockchains, but that would be based on having different fundamental ideas of what you want your network to represent. Whereas sharding is everyone has the same schema, everyone believes the same thing. You're just splitting it up for to address these the speed issues.
Gotcha. And you're saying that something like a 51% attack would be a lot easier to do because you just have to do it over a single shard.
Exactly. So the more parts you have, so the real balance is, like, you want to have enough people within a particular shard to maintain it, make sure it's highly secure, but you also want to have enough shards to make sure that it's fast, right? So the more shards you have, the faster it is, but the less people you have in the shards. The more people you have in the shards, the more secure it is, but the less it's going to help with the speed issues.
Okay, I don't want to take any thunder because I imagine you're probably going to, there's room for this on this slide for more bullets. I know something that's been growing very exponentially very recently. It's been out for a while, but it seems like finally is taking over is the Lightning Network. Is that where probably your next bullet or coming up?
It's the next bullet. It's like you're reading my mind. So the other idea is, rather than evolve the blockchain or split up the blockchain, there's this idea of adding layers on top of the blockchain. And this is the idea that everything on the blockchain doesn't necessarily need to have this level of verification and validation. You could look at things and saying, instead of saying like every cup of coffee needs to be on the blockchain, you could do things like every group of transactions. And so the Lightning Network is one of these really good ideas I'm building on top of the blockchain. And they call it a layer 2 technology. And the idea is, let's say I want to buy a coffee from Starbucks. And what I would do is I would open up a payment channel between myself and Starbucks. And I would put in, say, $100 and they would put in $0. And every time I want to buy a coffee, I can simply change the balance in our shared account. And the idea with this is that the blockchain, the main blockchain, only needs to be used to open this route and to close this route. It doesn't actually need to be used for the transactions in between. So the Lightning Network, the reason why it's really getting some power behind it now is that, let's say I open up that channel between Starbucks, and then I have a friend who I trade money with back and forth for whichever reasons. Well, my friend can then pay Starbucks through me. So it can go from our shared account to mine and Starbucks shared account right to Starbucks. So it allows you to gain access to everyone else who's connected to. So if I'm connected to Starbucks, it connects me to everyone else who's connected to Starbucks. So it really quickly builds these routes, and it allows you to get to people really quickly. So not everything that you deal with, you have to open up a payment channel. You would just need to be connected to someone who has a connection to that thing. And it could be a second order connection or a third order connection. So really quickly, with a few different channels being opened up, you'd have access to whatever you want. And the only real problem with this is that it does require locking up funds. So whichever of these routes that you decide to open up, you need to put some money into that account. And so that kind of one thing that might be put people off a little bit is kind of like buying different gift cards. But as I mentioned, you don't have to do this with everyone you want to transact with. You just have to connect to someone who's connected to a lot of different areas. And the network will naturally find what's the quickest route and what has transaction fees.
Now, does that free you up of all fees, or is there still a chance that people will be getting some transaction fee with the Lightning Network?
Yeah, you'll still get transaction fees, but the idea is to minimize that, right? And but speaking of no transaction fees, I love how this is working out. There's also this idea of having an individual blockchain, and this is actually a no transaction fee method. So Nano, which was formerly known as RayBlocks, has this idea of a block lattice. So rather than just simply having a main blockchain, you have this idea of a block lattice. And this is probably one of the most different technologies we've spoken about so far. It's the idea that everyone has their own blockchain or account chain to verify transactions. So whenever you transact on the network, you actually create one block per transaction yourself, rather than putting it onto the network and waiting for a miner to do this. So you perform a small proof of work yourself as a little competition. You do this cryptographic puzzle yourself, but the cool thing with the Nano is actually you can cache these ahead of time. So you can kind of pre-do the puzzles and get ready whenever you want to actually do a transaction. And this works really well because if someone was to try and, say, spam the network, they'd have to put some level of computational power behind themselves to gain access to do that. But for the average person, you can just pre-do these calculations and get ready to make your own blocks. And so where the idea of the lattice comes is that your blockchain, when you write to it, you can write, I'm going to send some money. So you have this send transaction, and someone else who you're dealing with will have a receive transaction. So what the network does, it actually connects your send transaction and their receive transaction, but it does it in an asynchronous way. So rather than having to put everything onto the network and wait for everything to synchronize, you can put your transaction out there, get validated, make sure that it's ready to go without having to wait for that person to finish theirs. So you do that, they do theirs on their time, and then the block lattice comes in connecting these transactions over time. So if you think about each blockchain as a vertical line, and each person, a vertical line over time, and each person puts their send or receive transaction along that vertical line, what they do is they connect these when both transactions are done, but for yourself, you only need to, your transaction is basically completed on your end once you write to your own blockchain. And then, so the idea is that instead of evolving the blockchain or dividing it up, adding layers or having individual blockchains, there's also the idea of something completely new. So blockchain is not the only distributed ledger technology that's possible. It's just the most popular. And as Larry mentioned, there's this idea of the hash graph. So hash graph is really quickly gaining a lot of steam behind it. And one of the big things they have is this idea of virtual voting. So rather than everyone on the network having to validate everything, they call it a gossip about gossip protocol. And the idea is that whenever you know something and you tell someone about that, they know what they know. They also know what you know. And when you pass that on to, say, the third person, over time, you know what other people already know. And if you know what they know, you know, based on their algorithm, how they would vote on something. So this allows the network to operate much more quickly, and it can actually do 250,000 transactions per second. So versus the 7 on the Bitcoin network, or even 64,000 for Visa, this is a very speedy technology. And one of the main complaints about it, though, is the fact that it's patented technology. So it is open code, so anybody can look at the code, make sure it looks okay, but it's not open source, so no one can actually change the code. And a lot of people don't like the idea that a corporation could essentially own the patents for a large part of the internet. So people who are developers really want to have this idea of the open source network. But Hashgraph is really taking a different approach to these things. Even with the consensus algorithm, what they're doing to bootstrap their network is they're saying, okay, to take over the network, you're going to need to have a 2/3 majority to invalidate someone else's transaction or stop the network. So rather than using a typical proof of work or even a proof of stake available to anyone, they have a bunch of globally distributed blue chip companies who have way more to lose than just the stake they put in. And they're the ones who are going to start the network by saying that we have no reason to work together. We're all trusted companies, so if we lose your trust, there's a lot more to lose than just the stake we put in. And so this is an interesting idea of how Hashgraph is getting this kind of super credibility, as a term, for their network, making sure that it's like all these big companies are behind it from day one. So it's a completely different approach than the kind of open source blockchain approach.
I want to interject here because it could actually lead to something for my students on their test. I don't like the way they word that open code versus open source, because everywhere else, open source and open code would be the same thing. It means I can see the code as opposed to open license that allows me to modify that code and resell it as mine. So we would say that Microsoft is closed source. You can't even see the source code. You get compiled code and you hope it's good. But a Linux is open source. You can see the source code. That doesn't mean you're allowed to modify Red Hat and make it yours. They own that. So I heard an interview with I forget the gentleman's name. It was actually the sales. There's two people involved with Hashgraph that I'd heard of. One was the tech behind it, and one was more the sales guy. And the sales guy was on Ivan on Tech one day, a special interview. And he said, well, I don't like to say open source because people think you can modify that. And I said, well, nobody in the Linux community would jump to that conclusion. And I thought it was really limiting their success, because when people hear that, they think, oh, well, he's going to be able to have hidden code in there that we don't know. And no, he's allowing you to look at that code and look for any type of vulnerabilities, look for any backdoors. The only thing is you're not allowed to take it and run with it.
Yeah, I mean, and I think it also depends on, I mean, the people who are getting into this, and again, it's going to be my next slide. But actually, let me jump there, and I'll mention about that. Okay. So there's this idea of when to jump into these networks, and the idea is obviously for developers, it's a great time. It's very exciting, and as Larry was mentioning there, developers look at things and they look at the idea of open source, and they think about it one way, whereas the average person could look at it completely differently, or even a Windows developer might look at it differently. Corporations are used to dealing with people that own patented technologies and have licensed things. I mean, even using a smartphone, there's licenses that go into that. So it's really, right now, it's largely developers that are on these networks and people who are, like you said, sales or investors in these technologies. And so they don't like the idea of this patented technology of Hashgraph, but that doesn't mean that a lot of people don't. Some people may take the idea of saying, like, okay, if it's a free and open license, as you mentioned, and it is open source in the fact that you can't modify it, but you can see it, that might be totally fine for everyone. Like you said, that's going to really help with adoption. So the idea of when to jump in, developers, I think 100% need to get on these things. You need to understand the blockchain and the distributed ledger technologies, because, like I said, Oracle and Google are already creating developer tools for these networks and allow you to create test versions in the cloud, so you don't have to worry about getting mass adoption for people to build out your technologies. But I agree with you, Larry. Like, they're really limiting themselves using the terminologies, because the people who are going to adopt these early are the developers. And so you need to speak their lingo versus, trying to use better marketing for everyone else. So when to jump into these things, there's obviously these problems that we know about. There's the issues with scalability, efficiency, there's the transaction costs, as well as the distribution with things like mining pools or someone being able to purchase the majority stake in a shard. But there's also these problems that we don't know about yet. And these are starting to come to light. The more they're used, there's things such as legal ramifications or taxes that when these networks were first put online didn't have anything. So now there's different asset classifications, different tax rates, depending on the different tokens that you're holding. So these things are all being developed right now. So for this to get massively adopted by the average person, it's really, there's a lot of things that we don't know about yet. And without having everyone on here, the more developers that are a part of this, the more of these issues we can find out ahead of time, and the more able we are to bring this to everyone else and make sure that they understand and want to participate. But there is early adopter advantages as well as disadvantages. And this comes in things like, the Bitcoin network is used very frequently now, and a lot of people have made a lot of money on that. And the idea is, let's say I went to you and said, okay, I'm selling gift cards to my new store. For every $1 you give me, I'll give you $100 of value. That's a fantastic deal. If you were to give someone $10,000 and they were to give you $1 million, that's really great. But the problem is, what if their store never opens and you have gift cards to something that doesn't exist? Or there's a better option available and there's no real need to use that store. And right now, even though a lot of people are building on the Ethereum network, there's no clear winners. There's no one that we know is going to be, this is the technology that's going to move forward. So if someone wants to jump into a particular network, there's no real one that is leading everybody else. And there's also this idea that really there's nothing on these networks yet. So if you were to buy these gift cards ahead of time, you could make potentially a ton of money. But if you're using it to actually purchase things, there's nothing there. There's nothing really to spend your tokens on. And again, if that particular technology doesn't take off, you could lose the money. So it's kind of a word to the wise if you're, never invest money in something that you can't afford to lose your investment. And so this brings us to this idea of a decentralized future. And we touched on a few of these today, like global payments, ownership, crowdfunding, and digital rights. But this just really scratches the surface of what these technologies can do. As I mentioned, each of these technologies could easily spend a half-hour presentation on. I think we're at about 50 minutes now, so I won't go too much into these different things, but I hope this gives you a good overview of that. These technologies have some real viability, really can affect different areas of our lives, and will be a huge thing in the future. So with that, thank you very much.
Thank you very much, Matt. There was one question that was cashed up a while ago, and that was, I think you tried to answer it. He said, is Bitcoin still the king? Or is there other technologies that you like better? And I think you said it, we don't know yet. Is that about right?
Yeah, and I think that Bitcoin is by far the biggest brand name out there. It's really well known. People are using it less as a method of transaction, and they're using it kind of as the gold standard. So with Bitcoin, there's only a certain amount of Bitcoin that'll ever be released. So it's an asset that you can invest in. You could potentially store money in. It's not really good, like I said, to use for a day-to-day method of transacting, and there's things
which
like
it was supposed to do, and that performance, what you said, 7 transactions per second, is going to kill it. It can't. Without the Lightning Network, that's not going to work that way.
Well, exactly, yeah.
But the idea that there's a fixed amount, I think, is so beautiful. So, one of the big concerns with money is that they could just keep printing more money. You can't keep printing Bitcoins. And because people will lose their private keys, there's goofballs like me out there. I didn't lose any. I didn't buy it for that reason. I let my wife buy it. And but I wanted to buy 21 coins when I first heard about the technology. I said, there's only going to be 21 million. We will be one in a million. But it hasn't worked out that way. We had as many as 6, and then recently when it went up from whatever 6 to 7, she sold it, and then it went to 8. Rubbed it into her. I was like, will you please just hold on? I'm one of these guys that believes it's likely to hit 100,000, $1 million in a coin. That's, I've been wrong before. She likes to point that out. But what I like about Bitcoin is that it's been around the longest, and it has yet to be hacked. So that, to me, gives me the most confidence. And the other thing is, because people lose them, it's only going to become deflationary. It can't be inflated. So I heard an estimate recently that over 4 million, they believe are already gone due to lost private.
Yeah. Oh, I don't believe it. And I mean, and it's kind of funny you mentioned with the Bitcoin network, like what it was originally intended to do. And that's kind of the neat thing is that, like with smart contracts, as I mentioned, I mean, what you write into the contract, that's canon. That's what's going to happen. And if you find out later on, like, oh man, that's not exactly what I meant to say, that's already out there, right? So the Bitcoin network has been, one of the best things about it is it hasn't been modified much. So we talked about these forks.
Right.
The forks aren't common. If it happened every other day, they're like, oh, let's change this, let's change that. It's not really secure. So the implementations of the Bitcoin network in particular, they've done their best not to modify it. And things like you said, if you change the rules of how the Bitcoins are released, like right now, every 10 minutes, 12.5 Bitcoin are released, and that happens. And every 4 years, that number gets halved. And so that's happened since the beginning and will continue to happen until, like you said, the 21 million Bitcoins are out there. So if they were to say, you know what, we're going to change it, we're actually going to, instead of 4 years, it's going to be 8 years. Well, that's going to lose a lot of faith in the network. And the valuation is based on these known conditions happening in the future.
Another thing you had up there very quickly, but I thought because of my students, and I'm always thinking selfishly of their needs to pass the test, we're actually in a module of access control right now. And one of the things you mentioned as a future solution or then is voting. And one of the things that the voting machines, particularly the Diebold voting machines, violate a principle that we discussed before this module started, but we say that all authentication systems should provide AAA. So that means, or identity management, that says I can authenticate, authorize an account. And the Diebold voting machines don't account for anything. So somebody could change a record and we wouldn't know it. And when they talk about, and I forget, we had a speaker, there was a video in the Abundance group, a guy who, was it Venezuela, where he was chased out of the country because they want to put the voting system on blockchain to prevent people from changing those records, that there would be accountability. And I think it's a great way to do voting. I think it's one of the best applications of blockchain.
Yeah, and like I said, I saw this graphic online. I had to put it up here. Definitely not by myself, but like I said, everything from, like I said, the record keeping, intellectual property, voting, ownership, title records, healthcare. Like there's so much that these technologies can do, and pretty much anything they touch, they do it better than the way we're doing it now.
Oh, one other thing that's always gotten me as a consensus protocol guy, as a router guy, and I don't know, what is your experience? You have a lot of IT experience. What is your experience with routing protocols? Like, particularly, I'm looking at OSPF versus EIGRP.
Yeah. So exactly. So are you saying like in comparison to how the Lightning Network works, or?
Well, here's what I want my students to get, because it's a testable concept of called what we're calling consensus here, and everybody knows that we're going to talk about, or we should have discussed already, the idea of convergence. How long does it take for all of the in routing, all the routers to know of a change in the network, which would be like an updated block? Well, one of the problems and what makes OSPF so much slower by comparison to EIGRP would be that OSPF feels that everybody needs to know about a change. So if I sent a packet to Matthew, and Matthew, like I wanted to get it to Parth, and normally I send it to Matthew, who sends it to Thomas, who sends it to Parth. But then Thomas is out that day, and Matthew's now going to send it to Sammy to give to Parth. Well, that doesn't change anything for me. I still give it to Matthew. But in OSPF, you would yell down to everybody in this area, go, hey, Tom's out. I'm going to be giving this stuff to Parth. And I go, oh, really? Does that change anything for me? No, you still just give it to me. I said, well, why'd you bother me? Yeah. So the idea of the IGRP is just tell the meaningful neighbors that about the change. Don't make everybody learn about things that don't matter to them. So the convergence time in OSPF can be 50 seconds, and in EIGRP it's like 5 seconds.
Yeah, exactly, and it's much quicker that way. And I forget the exact terminology on this, but there are I don't think they're called full nodes, but there's certain nodes on blockchain networks which you can broadcast to, which are kind of like more of your core routers for passing along those transactions versus just randomly throwing them out there. So a lot of the technologies are based on current routing technologies, right? And like you said, OSPF is I don't know. I've always kind of looked at it as like the basic routing protocol. It's very simple, very not quick, but it seems like a very simple, limited way of doing routing. And I think there's these ideas, like you said, of the virtual voting. You have the Lightning Network. I'm not sure on the Lightning Network how they do routing, but they kind of say they'll find the fastest route and they'll be able to do it. But again, as you mentioned, it really depends on what algorithms they use to find the quickest route.
And my understanding is the Lightning Network, speaking of routing, is on the Tor Network. Is that not true? The Onion routers?
Is on the Tor Network?
Yeah, I thought that they use the Onion routers. I double check that. But I thought
I'm not sure, to be honest.
Okay. Well, there was a question here. We need to keep an eye on corporate blockchain engineers not to too deeply shard our blockchain, as it could be seen as a security vulnerability that could be exploited and impact our blockchain. Other vulnerabilities that a corporate blockchain manager should be aware of. So what are some of the vulnerabilities you think of? Particularly you're seeing like there are countries that are implementing blockchain technologies that are not decentrally managed. They're quite centrally managed. They're just using their own crypto. So if you're doing something centrally managed, we've always got the same risk, I guess, right? That the central management system has to be trusted. They could roll back transactions and pretend something didn't happen.
Yeah, exactly. And again, it depends on your implementation, right? Like I said, if you have something like a hash graph or it doesn't even have to be hash graph, but hash graph has this idea of, they're like, okay, well, it's decentralized technology, but we're going to tell you who bootstraps the network. And this over time, we'll release this as more people come online. But if you do a system like that, and like I said, it is more not centrally managed, but it's controlled who bootstraps it. there's no saying that they're going to give up that power later on. And the same thing, if you create a countrywide or a corporate blockchain and you have whoever has the majority of the right on it, if it's proof of work, the computational power, or proof of stake, the largest number of stake, it can be in theory decentralized, but it's very easy to have this problem of limited distribution and someone being able to gain access. So it really depends on, you know, the implementation or using proof of stake, proof of work, some other thing, who's bootstrapping the network, who has the access to initially be on there, right? So the technology itself is designed to be distributed, but that doesn't guarantee it will be.
All right, Dino is asking, he said, if Ripple is centralized, is that true? Would you say XRP is a centralized blockchain?
XRP?
Yeah, Ripple?
Ripple, I'm not too familiar with Ripple, to be honest.
Okay, all right. So that's what a lot of banks are using. I didn't think it was centralized, but as Matt pointed out, to bootstrap a lot of these blockchains and graphs, is they frequently do say, well, we're going to start it off. We've got, and I forget who I was just listening to, we got 21 companies who are all going to work together to kick this out, and they're all member bodies, whatever. And then when we get enough miners out there, these guys can step back. But what's the guarantee they're going to do that? Another one I heard recently was that that these centrally managed systems can fork whenever they want, you know, and that's another consideration. They say, oh, we've just decided that we're gonna upgrade the code and whatever, and so that's again why people still like Bitcoin is that they haven't done that. It's been very stable all these years. Oh, another big hack though was the I've heard where the API sets to provide. So if you think of blockchain as a network protocol and then Bitcoin and stuff as applications, well, they create API sets to create applications, and these APIs have been hacked.
Yeah, well, exactly. And, you know, there's just, you know, it's kind of any sort of cryptography. As you mentioned, you know, there's people who will get on these things and they'll create a digital wallet with some funds and they can forget it, right? I always look at the idea, encryption is like meeting someone in a back alley. It's like no one else can necessarily listen into your conversation, but you don't know the person you're dealing with on the other end is actually legitimate, right? You could still use a blockchain technology and purchase something remotely, and the transaction could be validated. It could be like, yes, we 100% agree that you're giving this person money in exchange for this product. Well, they could ship you that product and it could not be what you said it would be. So that doesn't guarantee that things are going to work. It just verifies that, you know, everyone is agreeing
that the transaction did happen. All right, we've got, we really should be closing up, but I've got one other question somebody wrote in here, is Nathan, and it's something I thought about, that more than 3 miners in China appear to control more than 50% of the hash rate in Bitcoin. And that's a concern I have. You know, just because it takes 51%, but it doesn't, you know, that could be one organization, one country. So what do you think about that?
Oh, 100%. Yeah, exactly. So, so for example, for the Bitcoin network, there's really the idea when it initially came online was anyone can throw a computer up, anyone can do mining, anyone can make some money, right? Yeah. But these mining pools use these application-specific integrated circuits, these little machines that all they do is pull in energy and spit out Bitcoins, for lack of a better way of saying it.
It's a test objective for my students to remember what an ASIC is, right? We know that that's a processor dedicated to a given application. So that's how like routers work. They have ASICs that just run EIGRP or just run OSPF, and they can do things much faster.
Yeah, so there's mining ASICs as well, right? So to purchase these things, it's quite expensive. Like if you wanted to, you know, stake some coins, and you could say like, okay, most people are putting $1 million in, I'm going to put $1,000 in. Well, you can still become a miner on a proof of stake network. You're just going to get 1/1000th of the opportunities to mine. Whereas in a proof of work, to compete in these competitions, because like you said, you're guessing these random numbers. If you have an average computer, there's basically 0 chance you're ever going to do it. You need to have these ASICs that allow you to crunch through these things. So these companies that have these will, continuously invest in more of them. So you get them back, you can invest, you can get larger and larger. Right. So whether it's a few parties, like, 3 is obviously a small number, and to have 3 miners together that can control 51% of the network completely undermines the entire purpose of the network, right? Exactly. And it's the same thing as going back to the idea of a corporate blockchain. If you have, this distributed network, but, the owners of the corporation or, particular division controls the majority stake, it's not necessarily going to, work out the way that it does in theory.
Nice. Nice. I wish I could keep you around. I've got so many other things I'd like to talk about here, because I really think that as a router guy, I'd like to see routing protocols adopt blockchain technology. Oh, and I want to clear up something I said, more for anybody listening to this later. I said routers use Asics, but actually it's more probably appropriate to say that layer 3 switches use Asics. Our routers are probably more general purpose processors because they do more than just route. So that was, as I said that, I was like, oh, someone's going to play that back and go, oh, he thinks he knows route. But thank you so much. I had so much fun the last time. This was great. And I think I did the same thing last time. I want to keep you around. But anybody, any more closing questions for Matthew before we take another little break here? Thanks, Nathan Fair. Alrighty. Well, Matthew, I can't thank you enough. I appreciate it very much, and I remember to hit the record button. So I'll publish this out, and hopefully over the weekend I'll be able to pull this out of the 5-hour video evolve today and just get this up on the web. So thank you very much, everybody. Give me a big hand.
Thank you very much, everyone. Thanks for having me.
All right. Pause the recording, guys.